Hello there, welcome and thank you for joining us for another EDA Summit Series event. My name is Mark Jeffries and I am delighted and honoured to return as your host and your MC. This one is on the topic of Kafka Mesh. Now, Kafka Mesh is a concept you may well remember that was first introduced at our annual EDA Summit in May by Sumeet Puri, Chief Technology Solutions Officer at Solace. That presentation, it turned out, was so popular, and we've had so many requests for more detailed information that we invited him to deliver a second presentation with more guidance on how to build a Kafka mesh so you can address important operational challenges and opportunities. He in turn asked his colleague Thomas TK Kunumpurath, Solace's Vice President of Systems Engineering, to demonstrate an approach he and his team have developed. Sumeet, Thomas, welcome, and thank you for leading this much anticipated session. I'm going to hand things over to you in just a moment, but before I do, let's take a quick poll to see what different flavors of Kafka that are in use by you, our audience, right now. So please let us know. Here's the question. What version or versions of Kafka are currently in use at your organization? And here are some choices. Apache Kafka, Confluent, Amazon MSK, Azure Event Hubs for Apache Kafka, Avon, Red Hat AMQ, Cloudera, or other. Thank you for your participation. I'll let those responses speak for themselves. Sumeet, TK, over to you.
Thanks again, Mark. As you've mentioned, it's been a few months, May the 4th to be the precise date, where at the EDA Summit, I talked about the Kafka mesh, and it's been a very hot topic. Again, Kafka has been extremely popular. So today we are going to do the next session where we are going to go deeper into the solution, not just the concept, but how are we going to approach the Kafka mesh problem technically, how are we going to build it? And later TK is also going to show us a demo on how we are approaching building the Kafka mesh and empowering enterprises with the solution. So as we get going, this is a recap of the slides, the talk that I gave. I'm trying to be concise here. So enterprises today, as we know, are more distributed than ever. And this distribution has been powered by a few things. First and foremost, network is faster than disk for the past few years. And with 5G, the capabilities of this network, even at the consumer grade, are becoming increasingly faster. And as a result, the event mesh or the capability of distributing applications has gone down even to the edge. So from edge to cloud to core, applications are more distributed than ever. And leveraging this distribution are lots and lots of connected devices. So IoT architectures, IoT projects are increasing more than ever before, whether it's connected factories, whether it's connected logistics. In fact, I had the pleasure of attending the opening of Singapore's next generation port a few weeks ago. And that port is pretty much fully automated. So from cranes to loaders to trucks, everything is IoT enabled on 5G enabled fingers, where you have event mesh or edge mesh nodes connecting those devices. And then, of course, there are on-premises and other older systems which need this information. For command and control scenarios, for real-time analytical scenarios, because the underlying network is faster than this today, streaming has become the predominant paradigm to do analytics and to also do command and control. And of course, Kafka has a lot to do in this evolution. So whether it's open source Apache Kafka, which started at LinkedIn, or Confluent, Kafka MSK, Azure Event Hubs with their Kafka APIs, and a lot of other distributions of Kafka have become the darling of developers, and they've led this innovation. They've fueled this fire of building event-driven architectures, event-driven applications more than ever before. So given that background, there are some new patterns and new challenges that are emerging. So while we say that distributed applications are becoming increasingly popular, that leads to this challenge of hybrid cloud deployment, especially across islands of Kafka. So if you have a Kafka cluster on premises, could be one flavor, let's say Apache Kafka, you may have an MSK in AWS. How do you actually move events from one to the other? Because your applications are getting distributed. They want those events to be where the application business logic needs to be. Another challenge, again, different but related, is interoperating with various API management platforms. So Kafka is being used a lot for analytics, sometimes for microservices, but as APIs are being exposed, whether it's through marketplaces or whether it's through internal or external portals, you need to connect some of these API and platforms to the streaming layer. In fact, at the EDA summit also, we heard Roche talk about using APIs plus events to reduce patients' time to therapy by 50%. So real impact happening, but the challenge, of course, needs to be solved. A third challenge, again, with those streaming devices, those IoT sensors, if you were to do analytics, if you were to calculate, let's say, from a preventive maintenance standpoint, what's the health of a machine on a factory floor, and when do you want to replace parts, or you want to do historical analytics on which particular brand of a part worked better than others, you may want to stream those event streams into Kafka for stream processing reasons. And again, those connectivities have to be built because those devices will not directly connect to Kafka. They'll be connecting over some sort of an MQTT backbone. And while we see these three different patterns, cloud native, API-based, and IoT integrations, we also have to make sure that from a non-functional standpoint, filtering while preserving order is critical. So only the right amount of data needs to go to the right Kafka clusters or applications and in sequence. You don't want your cancels for a particular order come before the order. And you only want certain, as you partition some of your data, you want the information to be delivered in the order that you want. Then the biggest problem of replicating, in fact, the word itself demonstrates the problem. How do you move information between or among these Kafka clusters, these islands of Kafka? Are you replicating the old database style moving logs around, or are you streaming? Like Kafka is all about streaming, but when it comes to replicating information among clusters of Kafka, why won't we stream there? So why replicate, right? And lots of complexity there, actually. Lots of flavors from mirror maker to replicator to various flavors trying to solve this problem. And then last but not the least, just the management of all of these ecosystems. How do you universally catalog all of the various flavors of Kafka, the event streams that are there inside these? So looking at these challenges, that is where we had conceptualized the solution, the Kafka mesh. I won't steal TK's thunder. He's going to talk a lot more about it. But essentially, it's a network of event brokers which solve some of these problems. So filtered, guaranteed, secure, WAN-optimized streaming of events, and they connect natively to Kafka clusters of all flavors. They also connect to other applications from microservices to serverless functions to IoT devices, connected enterprise, API platforms, iPaaS. So Kafka to Kafka, Kafka to non-Kafka in a location agnostic, cloud agnostic manner. How do you stream that information? That is what Kafka Mesh is all about. So also over the months, we've always got this question that, hey, I already have Kafka and I'm solving some of these problems. Why Kafka Mesh? While people are curious, they want to know, that they relate to the problems. There's also, again, architects are skeptical people and they ought to ask the question. So to summarize what I've said, mesh streaming So we can connect these islands of Kafka, but why replicate? Why just move logs? Why not have event by event filtered stream of information go from source to destination, which is automatically intelligently learned and is compressed and is encrypted, and it's guaranteed from a delivery standpoint, and it's intelligent that only a single copy is delivered and any fan out is done at the edge. So true streaming among these Kafka clusters and non-Kafka applications. And then also Kafka discovery. How do you make sense of the information, of those event streams, of those consumer groups, of those topics that are available in various Kafka environments? So Confluent has their own capability here. Some of the other Kafka instances may or may not have those capabilities. There are some third-party systems who are trying to offer to various degrees of maturity the ability to go and discover what is there in your Kafka estate. But that itself is a solution that is needed as these applications become more event-driven and more real-time. I touched upon a few examples. So again, liberating data from MQs, from ESBs, from existing systems, let's say a lot in payment platforms, from mainframes. How do you stream that information into Kafka, into, let's say, an MSK in this case, for fraud detection or for customer analytics, like payment information you want to be analyzed, and why do it on the mainframe? Why not leverage the cloud for it? So that's one scenario. Another scenario, again, from an IoT standpoint, information coming from connected devices. So you want to find out the health of a part. You want to find out driver behavior for, let's say, insurance reasons. So information is originating from non-Kafka environments, IoT sensors through MQTT brokers. They need to be processed for streaming, for stream processing in Kafka clusters, right? And a third use case is order management and inventory management in the retail sector. So we've, in recent times, done a lot of work in this space where, let's say, your order management system was built on Kafka, your e-commerce system, the vendor that you chose had some Kafka built in for all the right reasons, but then you also had a lot of SAP, you also had a lot of other non-Kafka applications, and probably your fulfillment system or your warehousing systems or your logistics management systems were built either on even serverless platforms, maybe on legacy. So how do you bring these two worlds together? So all of these problems are integrating islands of Kafka or integrating Kafka with non-Kafka applications in a real-time event streaming standpoint across multiple sites, or sometimes also on the same site. So to summarize, what can the Kafka mesh do for you, right? So all these problems, all these challenges, all these use cases that I've talked about, the Kafka mesh solves these problems by easily replicating Kafka to Kafka streams. You can subscribe to a subset of topics, not replicate everything. If you want orders of a particular SKU, that's all you get through a topic hierarchy. And of course, these streams are guaranteed in their replication with edge fan-out, so guaranteed as well as WAN optimized. They're very efficient. They are encrypted, secure, compressed. And this real-time connectivity is not just limited to Kafka, from Kafka to Kafka, but Kafka to all the other environments through open standards and adapters when needed. So native connectivity with MQTT, native connectivity with REST, native connectivity with AMQP and JMS, and a bunch of other connectors. Lastly, how do you make sense of all of this from a discovery, cataloging, governance standpoint? Like with API platforms, you have a full catalog of what is there in your API ecosystem or your service mesh. Similarly, for Kafka environments and also for non-Kafka events, what's your end-to-end catalog? If a new application wants to go and say, hey, give me a list of all orders that are coming in for a particular location, how do you find what's there on the mesh? So that's where the discovery and cataloging and the relationship visualization comes in. So that was my recap of what I talked about at the EDA Summit. Over to you, Mark.
All right, thanks for that, Sumeet. I'm curious to know if our audience is running into any of the challenges that you mentioned a bit earlier. So let's run a quick poll before we jump into TK's demo. All right, here we go. This is poll number 2. The question is, which of these challenges do you face today or think you're likely to face quite soon? Linking on-premise and cloud-based Kafka clusters. Connecting Kafka clusters with edge applications and IoT devices. Streaming data from millions of devices/vehicles to Kafka clusters. Filtering Kafka data streams while preserving order. Replicating data and events between different kinds of Kafka clusters. Managing and governing Kafka and non-Kafka event streams. And if you face a challenge that's not listed here, tell us in chat and we just may take that challenge up in Q&A. Thank you for your responses. Okay, TK, over to you.
Right, thanks a lot, Mark. And so Sumeet talked about these problems that people currently encounter with their Kafka deployments, and let's look at how they would solve them today. So at the end of the day, they use a mix of technologies and platforms that are non-standard, and at the end of the day, it becomes rather expensive to manage, monitor, and scale. There must be a better way. That's where, as Sumeet described, the Kafka mesh comes into play. So you could think of Kafka mesh as a uniform set of infrastructure and architecture that allow you to essentially overcome some of the challenges that you have with operationalizing Kafka clusters, making them IoT enabled, and also cross-communicating between different flavors of Kafka. Before we get into the demo, what I'd like to do is just go over a key concept of the Kafka mesh. That is really how Kafka records get translated into routable topics. So let's take, for example, a Kafka cluster that contains global orders for a retail conglomerate. This Kafka cluster is ordered by keys, and the keys in this case are the geographies that these stores belong to. And what happens when the Kafka cluster gets connected to the Kafka mesh, the Kafka mesh takes certain metadata from the Kafka records and essentially transforms it into what is known as a hierarchical topic. So in this case, a hierarchical topic is described by the geography, the store name, and the item. So in the first case, you could see that the Kafka record is keyed by the country US, and it's from the Acme store. And they're selling, this specific record represents a sale of paper. So we take the key and the headers, namely the store and the product, and we /delimit them. Likewise, the second record gets translated, the headers and the key gets translated into UK TJX clips, and the third record, IN Flipkart pencil. So once these records are translated into these routable topics, and just bear in mind as well that the payload is also attached to these records, is that you could start asking intelligent and real-time questions of your Kafka streams. For example, what if I wanted to get all events in sequence that originate from the US regardless of store? You just express a topic subscription with the wildcard US/greater than, which essentially means that any message that has a topic that begins with US will essentially be routed to the subscriber. And likewise, if I wanted to get all records or all events that originate from the Acme store, regardless of country that the purchase was made in, all I have to express a subscription as is */Acme/*. And then all records that match that specific topic pattern, which essentially means that it doesn't matter which country the record or the event originates from and what product the record mentions, that will be routed to the second subscriber. Likewise, if I wanted to understand globally across all my stores what pencils were sold from which stores, regardless of geography, all I have to express a subscription as is */*/pencils. So the key thing to take away from this slide is that your topic taxonomy for the Kafka mesh is a primary mechanism to route data, and it unlocks so many other benefits of the Kafka mesh. So now, since we have those fundamentals out of the way, let's dive into the demo. This is an early access version of our Kafka mesh. So the screens are subject to change, but a key aspect of the Kafka mesh is connectors, and there's a variety of connectors available. We have connectors into cloud native services, and as you can see, we also have a connector into Kafka. So let's go ahead and click the Kafka connector. Once I click the Kafka connector, I'm going to just enter a label for the connector. I'm going to enter the host for my Kafka cluster, which is running locally. And since this is an open Kafka cluster, I'm just going to set the authentication to none. Then the next thing I do is express what topic from Kafka that I want to transfer events from. Click OK, and my connector is created. So what I'm going to do next is I have a terminal window on the right-hand side, which I'm going to very shortly use to spin up a simulator that simulates order events into my Kafka cluster. And on the left-hand side, I'm using the CafDrop UI to get a visual representation of the records in my Kafka cluster. So what I'm going to do now is start the simulator. And as you can see, it will start pushing out orders in real time, simulated orders with products from a store, with the price, and a geography as well. The key thing to note here is that these records are keyed by country, as described in the previous slide. They also have headers associated with them. So they have the product and the store name as part of the headers. Those are the fields that we will be using to create the routable topics. And as you can see here, this is a very common problem with Kafka. Kafka ends up being a data store for all records, and getting this filtered stream from them can be challenging. For example, as described in the previous slide, what if I wanted orders just from the US geography? Or what if I wanted orders for products for the awesome steel shirt, regardless of which store they were sold out? Or what if I wanted orders from a specific store? What if I wanted a combination of those questions that I just asked? Doing that with Kafka can be challenging, and not only that, doing that in the order or in sequence presents a set of other challenges. So what I'm going to do next is going to show you how I'm going to be able to, in real time, express those subscriptions and then get these streams. So let's go ahead once again into the Kafka Mesh UI. I'm going to express a subscription so that it says US/Acme/star, which will get all orders from the Acme store and stream it to me in real time. Okay, as you can see here, as the Kafka records are produced on the right-hand side, these records are pushed through the Kafka mesh, and they're only related to the US Acme store, regardless of product. Okay. Now you could do this with another topic subscription. So now let's figure out all orders that originate from the UK and the TJX store. So again, I'm going to click subscribe, and again, in real time, what you're going to see is records that have those specific characteristics, namely originate from the UK, belong to the TJX store, and regardless of product, instantly flow to you. So you're getting these events from your Kafka cluster in real time through these dynamic subscriptions. And just to re-emphasize, they will be delivered in sequence as well. Since we've seen the Kafka mesh in action, let's look at some of the other benefits that the Kafka mesh gives you. Say, for example, again, you have a global orders Kafka cluster, and perhaps you want to spin up a new Kafka cluster that only contains your UK orders. All you have to do in this instance is obviously spin up your Kafka infrastructure, express that topic subscription as UK/greater than, and on demand, your records will flow from your global orders cluster to your UK orders cluster. Likewise, if I wanted to spin up a US orders cluster, I express that a similar topic subscription, only this time with the US/greater than, and all records from the global orders cluster that originates from the US will flow to the US orders cluster. And I could do this with any combination of the topic hierarchy. For example, if I wanted my Kafka cluster just to contain pencils, all I had to do as expressed in the previous slide, just express a topic subscription with */*/pencils. So the richness of your topic hierarchy allows you to do this fine-grained filtering. And again, I want to re-emphasize that these events will always be delivered in sequence or in order to the end customer or end user. Another key capability of the Kafka mesh is enabling event streaming from your edge devices or your IoT devices using the MQTT protocol. And the Kafka mesh also has first-class support for REST as a protocol. So you could essentially integrate your Kafka mesh and by extension your Kafka clusters with API management solutions. The next key capability is store and forward. So this is very critical in locations where there isn't a reliable network connection. And so in this case, you're sending orders from your global order Kafka cluster to your US orders Kafka cluster using that topic filter that was previously explained. And what happens when there's a network break between these two Kafka clusters? What happens is that the events will accumulate, in this case on the near side, which is your global orders Kafka cluster's Kafka mesh. And then once the link is restored, all accumulated events will flow across the mesh instantaneously. So it provides that real-time guarantees around message delivery, even in the case of a network outage. Another key capability of the Kafka mesh is native integration with cloud-native services. So in this diagram, we're not only fanning out from an Apache Kafka cluster to various Kafka offerings in clouds. For example, in AWS, we're fanning it out to MSK. In Azure, we're fanning it out to Event Hubs. And in Google Cloud, we're fanning it out to Confluent Cloud. The Kafka mesh also gives you the ability to fan out the events to cloud native services. So not only in this case, am I sending an event from my global orders Kafka cluster to an AWS MSK installation, I'm also forwarding it to an AWS Lambda for a serverless compute process. So the key thing here is that the event, in this case, an order, traverses the Kafka mesh once from the global orders Kafka cluster to the US orders Kafka cluster, and it is fanned out at the edge. So only in AWS does the event go in two directions. Your publisher, your Kafka cluster, is only sending the event once from source to destination. And that holds true for the other clouds as well in this diagram. Now, as you could imagine, once you start building your Kafka mesh, it might start extending geographies, it might start extending to different cloud regions, it might start extending from on-premises to the cloud, and you're going to end up with a rather expansive hierarchy or topology for your Kafka mesh. Now, a key component of the Kafka mesh is also understanding where your events are at all time or where your Kafka records are at all time. So distributed tracing gives you that functionality. It allows you to instantly be notified where your specific record or event is within your Kafka mesh when it entered the Kafka mesh, when it left the Kafka mesh, and how many hops it took to get there. And the Kafka mesh does this through the Open Telemetry standard. So it can be integrated with any monitoring solution that supports that spec. Now, another key capability of the Kafka mesh is just managing your event stream. So adopting an event-driven architecture, whether it be with Kafka or any other technology, is easy. Managing it is hard. And so what the management capabilities of the Kafka mesh gives you is the ability to get a visual representation of your event streams and how they connect to each other. And also it provides developers and architects and data scientists with a catalog. So if a developer wanted to come in and understand what the order record looked like, he would be able to search in this catalog, understand all order events that are available within the Kafka mesh or the Kafka clusters, click into it, understand its schema, understand its topic, and very quickly be able to develop applications against that specific event stream. So we at Solace, we build the technology that underpins the Kafka mesh, and it consists of various components that have integrations not only with IoT and distributed trace, it also integrates natively into various iPaaS and API management solutions. And the core components of it are an event broker, a monitoring solution, and a management plane on top of it. And governing all this is the event portal that will allow you to manage your event streams, whether it be Kafka or some other event streaming product that is currently used within your organization. All right, thanks a lot. Now I'm going to pass it over to Sumeet for some closing thoughts, but just a reminder, if you do have any questions, please do put them in the Q&A box and we'll be able to get to them.
Thanks a lot, TK. That was amazing. So my final thoughts, and this is an example that we've been using quite a bit with other architects, with customers, with business people, and it seems to resonate, right? So event-driven architecture, event meshes, Kafka meshes, these are complex topics for business people, for anybody to grapple with, because they're not very visual. But we're all used to Twitter. So as we subscribe to the hashtags that we care about in the Twitter ecosystem, so let's say if you're curious to know about what is going on in the crypto world, you might subscribe to the hashtag crypto or Bitcoin or maybe Elon Musk. So you subscribe to the information that you care about. What do we do if we want to do the same thing for the enterprise? It's the same concept, just that these hashtags have now been transformed to topics. And these could be Kafka topics, or these could be MQTT style or AMQP style topics, because the Kafka mesh speaks both Kafka and non-Kafka protocols. So here are a couple of examples. So if you want to subscribe to payments that were initiated in the US, corporate payments, that's the first topic, pay/init version 1 corporate US. And that's exactly what you wanted to know. That's what your payment processor is interested in. That's the topic that you subscribe to. Or let's say your application, your consuming application is an ESB or an APIM application, or it could even be a modern, let's say, a serverless application that is consuming information over REST or MQTT. You could be saying, give me all payments that have been initiated, so pay init. I don't care about any version. I can handle all versions, so star for that. Whether it's corporate banking, personal banking, give me all of that, so star for that, but from Singapore. So you're tuning into your enterprise. Similarly, the next example is about boarding passes for Emirates for flights originating in DXB, Dubai, that have been scanned independent of the passenger's PNR. And then there are various examples of order topics. So topics with wildcards, and these are all based on standards. MQTT standards of plus and hash are supported. JMS standard with stars and greater than are supported. REST with slash separated strings are supported. But simply speaking, is the Twitter of your enterprise. And then the event portal catalogs all of those things. So with that, I'd like to hand it back to Mark to take us home. Thank you.
Sumeet and TK, thank you very much. You know, we have lots of questions coming in through the Q&A, so let's jump right in now so we can get to as many as possible. We appreciate it. And by the way, you still have time to send your questions into the Q&A. We'll do as much as we can. And then obviously those that we don't answer, we will find a way to get those questions answered a little bit later on in follow-up communication. But let's see, I'm going to make sure my screen is correct. Here we go. All right, so question one. And Sumeet, I'm going to aim this one at you, if that's all right. How does Kafka Mesh integrate? Excuse me, question one is actually going to go to Sumeet. Yeah, is the Kafka Mesh offered as a SaaS or is it self-deployed? That's the first question to you, Sumeet.
Yeah, thanks, Mark, and thanks a lot again for the participants asking those questions. I see lots and lots of them are coming, so keep coming with more and more. So Kafka Mesh is offered as a SaaS, so you can turn it on. It is cloud managed, so you can have these mesh nodes, Kafka mesh nodes deployed wherever you like, so proximate to your on-premises Apache Kafka or Confluent Kafka or an Event Hubs or an MSK system. All centrally managed and monitored, and the event catalog is also central, and that's how you would deploy it as a SaaS. But in certain scenarios, let's say you're unable to consume a SaaS because you're in defense and you're on disconnected networks, then we can also have this self-managed. So both options are available.
Nice. Thank you very much for that. TK, question for you now. How does Kafka Mesh integrate with legacy messaging products? That's the question.
Yeah, so we have a connector ecosystem. So if you have products like IBM MQ or TIBCO EMS, for example, we have a connector framework that allows you to take data from those systems and push it into the Kafka Mesh. And that connector ecosystem is ever expanding.
All right, thank you very much. Sumeet, I'm going to bounce it back to you now. And the question that's come in is, how does the Kafka Mesh enable a data mesh architecture?
So data mesh as a concept has been catching on. And again, for those of you who don't know, data mesh is all about federating your data. It's not a tool. It's all about having data moved such that the ownership of data remains distributed. It's not like a T+2 day sync into a data lake and then people get data from it. But for you to move this data in real time, which could be in different Kafka clusters, let's say the payments team have their own Kafka cluster and that's where the events are stored, or the order fulfillment team have their own cluster. So how do you get information from these clusters moving? And even non-Kafka systems such as an SAP system which is participating, which could hold a lot of data. So the Kafka mesh or the event mesh in general becomes that foundation for a data mesh to move data in real time. And the catalog of that data for you to understand what are the events on the mesh, that is taken care of by the event portal. So it's the underlying foundation. Kafka mesh is the underlying foundation for data movement in the data mesh, because after all, your data is getting more and more distributed.
Yes, very nice. Thank you for that. TK, how are messages routed between nodes in the Kafka mesh? That's the question.
Yeah, so as mentioned in the slide and the demo, what we do is we take key portions of the Kafka record, so namely the key for the record and the headers, and then we construct a topic. So once that bit of information is extracted, that record gets essentially turn into a routable data. And then your subscribers express a subscription on the Kafka mesh, and the data is then sent to it. So the key thing to recognize here is that subscription is made dynamically. And when a subscriber makes it, the data will be sent from the source Kafka cluster, wherever that's located, and find its way to the destination. And that route doesn't have to be predefined. It just instantly discovers where that data originates from and sends it dynamically from source to destination.
Nice, thank you for that. Sumeet, lots of questions around cost. I guess the basic one is the Kafka Mesh a paid product?
Yeah, so it is a paid product as well. You can get started for free. So there is the completely free standard edition that you can get started with. But as you start adding nodes to the mesh, it is a paid product. But it is available in various t-shirt sizes. So it starts at very affordable, and then depending on the number of nodes and the distribution of data, there are commercials around it.
All right, thank you for that. All right, so let's see. Aniket asks, can we create the real-time analytics using Kafka Mesh? Does Kafka Mesh have inbuilt analytic capability, or do we need to use external analytic tools?
Yeah,
Who
so
would like to take that? Yeah,
I'll take it. So the way you think of the Kafka mesh is that there could be various nodes of the Kafka mesh. So the Kafka mesh, think of it as a distribution mechanism. So one of the nodes of the Kafka mesh could be a Databricks or an Apache Spark or an S3 bucket or a Snowflake. The Kafka mesh sole responsibility is sending that information to the destination, whether it be an analytics store or whether it be an analytics package or whether it be a cloud storage bucket. The Kafka mesh can integrate with all those endpoints.
all right, that's great. Another attendee, some people submit names, some don't. So where I see a name, I'll read it out. No name here, but what you've been talking about, is it only available in Solace, or is Kafka Mesh available in Confluent Kafka itself?
Yeah, so I'll take that. So Kafka Mesh connects all kinds of Kafka clusters. So it supports Confluent, it supports open source Apache Kafka. You can connect Azure Event Hubs, which has a Kafka interface, AWS MSK, and all other flavors of Kafka. And it can also connect non-Kafka systems such as an IBM MQ or as TK mentioned, for analytics, Spark or Beam or any of those systems, or IoT capabilities with MQTT. So it's a mechanism to hydrate and move information across all kinds of Kafka and non-Kafka clusters.
Good, thank you for that. Lots of questions coming in, and I'll throw them at you, and if you can answer, great. If not, no worries. Another anonymous, why do this a challenge to you guys? Why do we need Event Mesh specifically when we can also filter the messages directly via open source integration frameworks?
Yeah, so I'll take that. So yes, certainly there's a variety of challenges associated with Kafka clusters. So one of the challenges is filtering. And certainly you can engineer or architect a piecemeal solution to solve that, whether it be something like KSQL or whether it be a custom microservice. But then when you talk about the other challenges, such as replicating data between Kafka clusters, IoT enabling your Kafka clusters, guaranteeing order or sequence within your Kafka records, you start building independent solutions to solve all these problems. So the whole idea for the Kafka mesh is that we take all these challenges and solve them with the uniform architecture and uniform platform. And we do it more efficiently. With WAN optimization, we only send the data once from one node to another and fan out at the edge. So lots of details there, but in summary, variety of messages, variety of challenges that the Kafka mesh solves, and filtering is a subset of the challenges.
Thank you for that. Sumeet, I want to pick you up on something you said right at the end of your comments about conversations with people in the business in general. This is a layer that has complexity to it. You said that yourself. Any tips that you would share with our audience on how to introduce these concepts, have these conversations with other stakeholders across the business who do not share the same tech knowledge?
Yeah, that's an excellent point, Mark. And you need business to fund any IT initiative, so it's extremely important to have those conversations, right? So how do you explain the Kafka mesh or Kafka or event-driven architecture to a CFO or line of business head? What I've experienced in my interactions, when you talk to people about tuning in to your business, whether it's for insights or applications, and tuning in to these events with topics, that seems to resonate. So that's where the Twitter of the enterprise example that I was using. So if you want to find out all orders for ice cream in Singapore, that's an event that is floating on the mesh. Now that could have originated from an order management system coming from Kafka, and the tracking of that order could be an IoT feed. That's a location event coming from an MQTT interface. What if you were able to tune in and extend this to your consumers in real time? What would that mean for customer experience? And usually when you explain it to business people like that, an event is an occurrence, right? It's a noun plus a verb. So initiated, order canceled. And with that, what we've observed, I've personally experienced, business people tend to say, yeah, I can think of these orders. And yes, I want to put them in motion.
I like that. And it's important, isn't it, to find a way to translate the genius of this idea into the language of the business. Exactly.
And it's been around for a while, right? Foreign exchange trading has been based on these architectures for 20 years. It's just that now, because, and I say this quite often, Mark, network today is faster than disk. And that's why these concepts are applicable to mainstream data movement. What used to be files earlier, now even music and movies are being streamed. So why not events?
Absolutely. Thank you for that, Sumeet. All right, more questions coming in. TK, this one's for you. Some of these questions are basically essay length. I'll try and edit as we go. TK, you state that with Kafka Mesh, you can easily replicate Kafka to Kafka event streams. Isn't the whole point of a natively distributed Kafka cluster to replicate events across the distinct Kafka brokers in the cluster?
Yeah, absolutely. So that is an accurate representation. So you think about a single Kafka deployment, you have a Zookeeper node and various broker nodes, and that's typically deployed in a singular cloud region or in a singular data center. What we're talking about is once you have a global enterprise, for example, you're going to have many Kafka deployments. So you could have a Kafka deployment in US East 1, you could have another Kafka deployment in US East 2, you could have another Kafka deployment in your data center, you could have another Kafka deployment in a different public cloud. And if you need a mechanism to send data from between all these different independent Kafka deployments, and there really isn't a standardized solution to do that. There's a hodgepodge of solutions out there in the market. And what the Kafka Mesh enables is enabling that data movement between your various Kafka deployments, no matter where they're deployed.
Brilliant. Thank you for that. I'm looking, I think, TK, this next one might come to you as well, possibly. Can we do, Viral asks, can we do data analysis by sending huge amounts of data from relational databases to Kafka?
Yeah, so the Kafka Mesh can, for example, if you have a database on premises in your data center and you have a Kafka deployment in the cloud, it could be Confluent Cloud, it could be Amazon MSK, it could be Event Hubs. The Kafka Mesh can take those, essentially integrate with your database, take those records from your on-prem database, send them to the cloud, and ultimately to the Kafka cluster in the cloud for analytics, for distribution and analytics. And so the Kafka Mesh, again, just to reemphasize, excels at data movement. And then once it's delivered to the destination,
you could integrate it with any number of tools, including a data store or a database.
Thank you very much for that one. One of our attendees, Supa, submitted a variety of questions. Supa, thank you very much for that. Here's one. What is the difference between Kafka Mesh and advanced event mesh?
That's a great question. So, see, the advanced event mesh is the SAP version of the event mesh, right? So when SAP provides the advanced event mesh capability, what it does is exactly similar to what TK explained and demoed. Now, the Kafka mesh capability of this connector-less integration into Kafka clusters is going to get rolled out into the advanced event mesh as well. As TK said, this is the early access, it's under development. As it goes through more and more QA cycles, the advanced event mesh will also have Kafka mesh capabilities built in, but it also has a bit more because it has all the SAP integration also that is getting built in. So they are not one or the other, it'll be a union of both.
Nice, thank you for that. Another anonymous question. If I have multiple nodes in a Kafka mesh, can I track when a specific event entered and left that Kafka mesh?
Yeah, that's a great question. And it's something that we at Solace are very excited about. So we're going to be first to market with distributed trace, which essentially means whenever an event or a record enters a Kafka mesh, the mesh will output OpenTelemetry-based events or OpenTelemetry-based standard-based events that allow you to track when an event enters a Kafka mesh, when it leaves a Kafka mesh. So you could think about a use case for orders, as I described in the demo. If you want to track when an order entered the Kafka mesh and how long it took to be processed, you could do that with the distributed trace feature that we have enabled. And this becomes more important as you start adopting a Kafka mesh that spans various geographies, various clouds, getting real-time visibility into when events entered and left the Kafka mesh become of paramount importance to enforce or to understand SLAs that you could offer to your end users or customers.
Thank you for that. Rakesh wanted just to double check some details, and he asks, you mentioned store and forward for guaranteed delivery in case of failures. Where the data is stored, where is the data stored till it's forwarded is the question.
Yeah, so the data is stored on the Kafka mesh, essentially. So you could think of a Kafka mesh as a extension of your local Kafka cluster. So the data goes from your Kafka cluster to the Kafka mesh, to a node of the Kafka mesh. And if there is a network break or a network interruption, it will be stored in that node. And then when the network is operational again, it will be taken from that node and forwarded on to the end destination.
All right, we've time for a couple more questions. Then I'm going to ask you both for just some very brief closing comments or advice, words of wisdom for our amazing audience. Madhu asks, how are you differentiating between open source or from open source to competitors?
Yeah, so probably I'll take that. It's a very broad question. So
yes,
open source, so Kafka mesh is a novel concept, right? So to my knowledge, there is no other open source Kafka mesh solution out there yet. You can cobble up a mesh in a complicated manner by having Kafka connector infrastructure deployed, connect various Kafka nodes, but it doesn't do all the filtering, the wildcard routing, the WAN optimization, the security, access control. None of those things would be available in those kinds of setups. Of course, a developer could code his or her way into all of them, but then that's not the idea.
right.
Second question is, how do you compare the event mesh or these Solace event broker nodes with Kafka? That's a topic by itself, and I won't get too much into those details. You can check those differences out, but at a very high level, Kafka for petabytes of replay and analytical use cases and stream processing is very good. It was built for that. When you look at pure operational use cases, an SAP or an MQ system getting connected or MQTT systems, Then you need in-order delivery, you need wildcard routing. So those kind of use cases, queue-based use cases, wildcard topics-based use cases, the event mesh nodes are more useful. So they are often deployed together, but we can have more details on various forums.
Of course. Thank you for that. All right, final audience question, and then I would love your closing thoughts. This comes from Sean. How can Kafka Mesh help to fill the gaps for multi-region DR in AWS?
Yeah, it's exactly built for those kinds of scenarios. So for business logic integration across sites and also DR replication across sites. So let's say you have MSK instances or other custom, let's say you're running Confluent or Apache Kafka on certain AWS regions, and then you're also having MSK on certain AWS regions. The Kafka mesh basically replicates the topics that you care about from one region to the other, so that you have data available, those Kafka events available in more than one site. In fact, certain organizations, for compliance reasons, may want to have DR replication to a completely different cloud. So it could be between AWS and GCP, or AWS and Azure, or even on-premises. So all of those scenarios are covered.
Very good. All right, our time is up, so 30 seconds maximum. Your final words of wisdom that you would share with our audience. TK, I'll start with you.
Yeah, sure. So the Kafka mesh is something that we at Solace are very excited about, and I encourage everybody in the audience to talk to us or set up a meeting with us. We'd be happy to take a meeting with any of you and run you through the Kafka mesh in more detail.
Thank you, TK. Sumeet, lastly.
Yeah, again, thanks a lot for your time. And there are still a lot of questions that we unfortunately could not get through because of time, but reach out to us, connect to us via LinkedIn, connect to us via the event, and we'll be happy to have a one-on-one conversation, or even maybe a Q&A session as a follow-up for this. But it's a pretty interesting novel concept, Kafka mesh, on the back of the popularity of Kafka. So looking forward to innovating with all of you.
All right, Sumeet, TK, thank you both very much indeed. We appreciate it. And again, let me echo our presenters' thanks. Thanks to all of you for tuning in to our third EDA Summit Series event. We hope you found this session to be valuable. And of course, you learned even more new things. If you've missed our previous sessions, you can catch them at edasummit.com/series. Also, stay tuned and keep a lookout for details for our next session on the same site, edasummit.com/series. Thanks again for joining us today, and we hope to see you again soon.